Welcome to Night Cosmos Sleep. Earth only truly begins to feel small when human beings leave it behind. From the cupola windows of the International Space Station, our planet no longer appears as a vast world, but as a blue and white sphere, drifting quietly through a darkness that seems almost endless. Bands of clouds sweep across the oceans. City lights slowly emerge on the night side, and the atmosphere becomes nothing more than a thin, glowing line wrapped around every form of life we know. Within that view lies everything humanity has ever known: crowded cities, lands divided by conflict, families being reunited, people taking their first breath, and memories that have faded with time. Yet from this distance, every border disappears. There is no visible sign of where one nation ends or where a dispute begins. There is only one planet, suspended in the darkness. Many astronauts have described this moment with a sense of wonder, peace, and profound emotion. But beneath that almost perfect beauty, another feeling often begins to surface: unease at the sight of a world so alone, protected by an atmosphere so thin, with no other refuge anywhere nearby. What frightened them was not something hidden in the depths of space. It was what they had suddenly realized about Earth itself. How can a single perspective change the way human beings understand their home, one another, and their place in the universe? The answer begins when the familiar point of view is no longer wide enough to contain the whole truth. The moment the rocket leaves the launch pad, Earth is still a familiar ground, trembling violently below. Through the small window, the structures surrounding the launch site quickly shrink away, roads become thin lines, and the coastline begins to appear as a faint curve between land and water. Within only a few minutes, a place that once seemed too vast to take in all at once begins to fit inside a single view. The initial excitement of rising higher and higher gradually gives way to a realization that is difficult to name. On the ground, people usually define their location through things that are close at hand: a home, a city, a mountain, or a familiar road. As the altitude increases, those landmarks disappear one by one. Buildings are no longer large enough to distinguish. Vehicles become tiny points and then vanish entirely, and a city is reduced to a patch of color surrounded by much larger regions. This transformation does not unfold over many hours, but within the span of time it might take to complete an ordinary morning. Clouds are among the first signs that the entire perspective has been reversed. From the ground, clouds are always overhead and are often seen as the final boundary of the sky. But as the spacecraft rises through the lower layers of the atmosphere, those clouds gradually fall below, spreading like white fields across oceans and continents. What once concealed the sky now becomes part of the planet's surface. That reversal alone is enough to begin changing the sense of direction. The higher the spacecraft climbs, the less the horizon resembles a straight line. At first, the curvature is so slight that it could almost be mistaken for an effect of the glass or the viewing angle. Then the blue and white surface below slowly bends into a clear arc, stretching from one side of the window to the other. Earth no longer looks like an endless expanse opening ahead. It begins to appear as an object with a shape, a boundary, and a place within space. This transition happens faster than the mind can fully adjust. Only minutes earlier, the astronaut was still inside a city, surrounded by sound, people, and solid ground. Now that city has disappeared from sight, while the entire familiar world is shrinking behind a pane of glass. There is no exact moment when Earth stops being the place beneath their feet and becomes something they can observe from the outside. That realization forms more slowly than the spacecraft moves. When the engines shut down and the spacecraft reaches orbit, the sensation changes again. The powerful thrust pressing the body into the seat is gone, but this does not mean gravity has disappeared. Gravity is still pulling the spacecraft and everyone inside it toward Earth. However, the spacecraft is moving sideways at such tremendous speed that the planet's surface curves away beneath it before it can fall to the ground. In this way, both the spacecraft and the astronauts remain in a continuous fall around Earth. This is why the condition in orbit is usually called microgravity rather than the complete absence of gravity. The body floats freely because everything nearby is falling at the same rate. A pen released into the air does not drop to the floor, but continues hovering nearby. Water does not pour in a stream, but gathers into round droplets. The ideas of up and down, which seem so obvious on Earth, suddenly lose any fixed direction. Inside the spacecraft, The floor is simply the surface chosen for equipment and handholds. One astronaut may work with their head pointed toward Earth, while another beside them faces the opposite direction. Neither person is truly upside down, because there is no absolute vertical inside the cabin. The body must learn to rely on vision and reference markers rather than the sensation of weight. At first, this freedom can feel exhilarating, but it also makes familiar space unexpectedly difficult to predict. Outside the window, Earth still fills almost the entire view. The International Space Station travels in low Earth orbit, only a few hundred kilometers above the surface, a very small distance compared with the planet's equatorial diameter of about 12,756 kilometers. For this reason, astronauts do not see Earth as a small globe suspended far away in the darkness. They see an immense portion of it directly below, close enough for clouds, oceans, and terrain to remain richly detailed. Yet, this closeness does not make the scale feel any more familiar. A continent can enter the window and drift out of sight before the observer has time to identify every landmark. Coastlines stretching for thousands of kilometers can be seen in a single glance. Mountain ranges that once required days to cross are reduced to folds across the surface. Distances once measured through long journeys on the ground are compressed by the speed of orbit. The International Space Station travels at approximately 28,000 kilometers per hour. At that speed, it completes one orbit around the planet in about 90 minutes. In the time it takes someone on the ground to watch most of a movie, the crew has crossed oceans, continents, daylight, and the darkness of night. No commercial flight offers the same sense of Earth's scale. The entire world continues drifting below like a landscape with no visible end. Each orbit also changes the way time is perceived. On Earth, sunrise usually marks the beginning of a day, while sunset signals its close. Aboard the station, that cycle repeats about 16 times every 24 hours. Roughly every 45 minutes, light appears or disappears beyond the curve of the planet. The familiar rhythm of day and night is replaced by a rapid sequence of transitions, too fast for the body to use as a natural clock. Sunrise in orbit does not begin with light slowly spreading across the ground. First, a thin band of color appears along Earth's edge. Then, over the course of only a few minutes, layers of blue, yellow, and orange begin to separate. The sun rises quickly, illuminating the station's solar panels and outer structure, while the planet below remains in darkness. The sight may repeat many times, but it rarely becomes ordinary. Each sunrise is a reminder that day and night are simply the result of motion. Sunset unfolds in reverse, yet it is no less sudden. Light withdraws from the surface, cities begin to appear, and the atmosphere glows briefly before fading from view. The space beyond the window turns black, while millions of lights remain scattered across the planet below. From orbit, night does not cover the entire Earth at once. It resembles a region of darkness slowly sweeping across the surface of a world that never stops moving. The oceans fill much of the view and often create the greatest sense of stillness. From this altitude, the sea does not reveal waves or small movements, but appears as a vast field of deep blue, sometimes reflecting sunlight in a brilliant streak. Clouds above it form structures hundreds of kilometers wide. A major storm may appear with a clearly defined eye, covering an area larger than many countries. The scale of weather suddenly becomes more visible than any map could make it. Deserts reveal another face of the planet. Regions of yellow, red, and brown stretch toward the horizon, divided by rocky mountains, dry valleys, and traces of ancient rivers. No sign marks where one landscape ends. Every transition happens gradually through changes in color and terrain. Seen from above, even places that appear empty reveal a geological history written across enormous layers, curves, and lines. Mountain ranges no longer block the view as they do from a valley. They appear as long chains of folds, sometimes covered in snow, extending across several climate zones. Low-angle sunlight casts shadows along their slopes, making the structure of the surface easier to see. Peaks once regarded as symbols of grandeur on the ground remain impressive, but now they rest upon a curve far greater than themselves. That shift in scale is one of the first things to make human power feel smaller. On the night side, cities emerge as glowing networks. Some regions gather into immense clusters, while roads connect them with thin lines of yellow-white light. Artificial illumination reveals where people live, but not what they are doing, what language they speak, or which nation they belong to. An entire civilization is visible only through the energy it leaves behind. The details that shape daily life disappear completely from this height. This is one of the quiet paradoxes of orbit. Astronauts can see more places in the same amount of time than anyone on the ground, yet they cannot see a single individual person. They witness the scale of the planet while losing sight of the small stories within it. A city of millions becomes a patch of light. A vast forest becomes an area of green. Distance expands the view while removing the things that feel most intimate. After many orbits, the first excitement begins to deepen into a different kind of attention. Astronauts no longer look only for famous landmarks or try to recognize their hometowns from the window. They begin to notice how clouds move, how darkness advances across continents, and how sunlight reflects from the sea. Earth no longer seems like a backdrop beneath the station. It becomes a vast system transforming from one moment to the next. This shift also reveals the limitations of the ordinary human perspective. On the ground, the planet seems motionless because its movements are either too large or too slow to feel directly. From orbit, the observer is the one moving rapidly while Earth continually changes below. Day gives way to night, oceans yield to continents, and clouds form before dissolving again. No diagram is needed. The movement of the entire planet becomes something that can be watched. What once felt like an endless flat surface now has a visible curve. The sky that once seemed to exist overhead has become a thin layer wrapped around the surface. Clouds no longer conceal the view, but reveal the scale of weather itself. Distances that once separated people are compressed within only a few minutes of motion. Each change forces the mind to reorganize its understanding of where it belongs. The astronauts are still not far enough away to see the whole Earth within a single frame. The planet remains too large and too close, continually filling the window with details that shift from moment to moment. Yet simply seeing its curvature, along with the boundary between light and darkness, is enough to weaken the feeling that the world extends without limit. Earth is no longer only the place where they live. It has become a finite object that can be observed from the outside. As the first sense of awe begins to settle, another layer of awareness starts to form. Below is not a motionless sphere hanging in space, but a world in constant movement, exchanging energy and changing without pause. Features that seem permanent from the ground are suddenly revealed as processes unfolding in real time. From here, the familiar planet begins to show a face that only distance can bring into view. Through the first few orbits, Earth no longer appears to be a motionless surface below. Clouds shift into broad bands, light changes color across the oceans, and darkness slowly spreads over the continents. Each time the astronauts return to the window, they encounter a different view. The planet seems to move through countless rhythms of its own, while still belonging to a single system. During the day, the blue of the oceans often fills most of the view. Above them, white clouds bend with the winds, stretching for hundreds of kilometers and sometimes curling into enormous spirals. Sunlight reflects from the water as a bright region that moves along with the spacecraft. At just the right angle, the ocean can flash like a mirror against the deep blue below. About 71% of Earth's surface is covered by water, but the oceans do more than give the planet its distinctive color. Water absorbs a vast amount of heat from the sun, stores it, and releases it more slowly than land, helping to soften rapid changes in temperature. It evaporates, forms clouds, returns to the surface as rain, and continues flowing through rivers, soil, and ice. This cycle connects places that seem separate into a single system. Large storms make the movement of the atmosphere especially clear. From orbit, they reveal almost complete spiral structures, with bands of cloud curling around a central region and spreading across an area larger than many countries. Their shape can be so beautiful that it is difficult to look away. Yet beneath that symmetry are powerful winds, towering waves, and communities trying to protect their lives. Distance often creates this kind of paradox. Heavy rain, deep snow, or ocean storms can become striking patterns when seen as part of a larger view, while remaining harsh and dangerous for those caught within them. A wider perspective reveals the structure of nature, but it also softens the visibility of individual experience. The same scene can appear peaceful from afar while holding deep instability on the ground. As the station passes over dry regions, blue gives way to shades of brown, yellow, and red. Deserts stretch outward in dunes, plateaus, salt flats, and traces of rivers that disappeared long ago. Angled sunlight brings out the folds and lines of the surface, revealing a geological history written in stone. Land that seems empty still carries the marks of water, wind, and transformations that unfolded over millions of years. Near the poles, ice and snow reflect sunlight into brilliant white regions. They do more than create a distinctive landscape. They also affect the way Earth receives energy, because ice reflects more light than dark water or land. Between these white regions and the oceans lie forests, grasslands, and farmland changing color with the seasons. The surface carries the combined traces of geology, climate, life, and human activity. Plants absorb light and use water and carbon dioxide to create living matter, releasing oxygen through photosynthesis. Individual leaves cannot be seen from orbit, but the green of vast regions reveals how deeply life has transformed the planet. Fields form geometric patterns that look very different from the natural curves of rivers and mountains. Even when no people are visible, civilization leaves its mark upon the land. As daylight withdraws from a continent, Earth takes on an entirely different appearance. Natural colors fade, while cities emerge as clusters of light connected by roads and populated areas. Densely inhabited regions form intricate networks, while deserts, oceans, and high mountains sink into darkness. Electric light reveals where people live, but it offers no glimpse of an individual face or story. The boundary between day and night is not a sharp line. It is a transitional region where light gradually fades across the curved surface, leaving one side still reflecting the sun while the other begins to glow with electricity. The station crosses this region in only a few minutes. From the window, an observer can watch darkness advance as cities appear one after another, as though the planet were lighting itself. Night also reveals sources of light that were not created by human beings. Lightning flashes within clouds, sometimes spreading across several clusters inside a vast storm system. Near the poles, auroras bend into green or red ribbons as charged particles from space interact with Earth's atmosphere and magnetic field. Even the darkest side of the planet is never truly still. If Earth were reduced to a sphere placed in a dark room, the oceans might look like a layer of blue paint covering its surface. In reality, they are an immense reservoir of heat and a network that transports energy around the planet. Ocean currents carry warm and cold water across enormous distances, influencing weather far from where those currents began. The blue seen from space conceals a complex system in constant motion below. The sun, about 150 million kilometers from Earth, supplies most of the energy that drives this system. The surface warms unevenly, creating differences between land and sea, and between the equator and the poles. These differences generate winds, ocean currents, and many patterns of weather. Clouds, ice, and bright surfaces reflect some sunlight back into space, while the atmosphere retains part of the heat radiated from the ground. This constantly shifting balance allows liquid water to remain and helps sustain an environment suitable for life. Water in the form of ice or vapor has been found in many places throughout the solar system, but Earth stands apart because of the vast amount of liquid water that has remained on its surface for so long. The oceans provide an environment for complex chemistry, regulate temperature, and support countless ecosystems. So far, Earth remains the only planet confirmed to harbor life. Every living organism ever known belongs to the blue world, drifting beneath that window. Seen from orbit, life does not appear as a separate layer that can be divided from rock, water, and air. It is woven into the colors of forests, the composition of the atmosphere, the fertility of soil, and the changes of the seasons. Living organisms depend on the planet, while also helping to transform it over billions of years. The oxygen human beings breathe, and many of Earth's chemical cycles carry the imprint of life. These connections are what make Earth seem as though it is breathing. Clouds form and dissolve. Forests change color. Ice expands and retreats, and oceans move under the influence of heat, wind, and gravity. There is no breath in the biological sense, but there are cycles repeating through day and night, through the seasons, and across much longer spans of time. Seen together, They create the impression of a world continually adjusting itself. The planet's beauty does not come from perfection or stillness. It emerges from the constant movement between water, air, land, light, and life. A river erodes stone while carrying sediment toward a delta. A storm causes destruction while also transporting heat and moisture. Every process reshapes the surface while taking part in a network far larger than itself. After many orbits, astronauts no longer search only for their homes or famous landmarks. They begin to notice how darkness moves across a continent, how clouds spread over the ocean, and how the color of the water changes near a river mouth. Phenomena once known only through maps become direct signs of a system at work. Each view through the window no longer shows an isolated scene, but reveals one part of a greater whole. The sense of peace comes from seeing all of these changes within a single picture. Below, there are still winds, waves, lightning, volcanoes, and billions of living organisms in motion, yet no single event covers the entire world. The oceans connect with the atmosphere, rain connects with the land, and sunlight connects the cycles of life to a star far away. Distance makes relationships that are invisible from the ground much easier to recognize. Then, amid all that beauty and motion, one detail begins to draw the eye. Above the oceans, clouds, and continents is a pale blue line, so thin that it almost disappears into the darkness. From below, it once seemed like a limitless sky. From space, it is only a fragile membrane surrounding this entire living world. Along the curved edge of Earth, sunrise does not begin with a sky gradually growing brighter as it does on the ground. Sunlight emerges from behind the planet and passes through the layers of gas wrapped around its surface. For a few brief moments, the horizon separates into bands of blue, orange, yellow, and sometimes a very faint shade of green. All of these colors are contained within a border so thin that it nearly dissolves into the darkness. From a window in orbit, the scene lasts only a few minutes before the white light of the sun floods in. Yet, in that brief interval, it reveals something that is difficult to sense while living below. The entire sky that once filled the field of view has now been compressed into a narrow ribbon of light. The air that holds clouds, wind, rain, and every human breath appears as a delicate membrane surrounding the planet. From the ground, the atmosphere always feels immense. We look upward but never see where it ends, only blue stretching toward the horizon. An airplane can travel through the air for many hours without ever leaving the layer of gas surrounding Earth. Because it is always present, the sky is easy to imagine as an almost limitless expanse. The view from outside completely changes that impression. Beneath the blue rim lie oceans, continents, and cloud systems extending for thousands of kilometers. Above it is the blackness of space, where there is not enough air to breathe or to scatter light into a familiar sky. Between those two immense regions, the environment in which human beings can live occupies only a very narrow range. The atmosphere does not end at an invisible wall. As altitude increases, gas molecules gradually become more widely separated until the distances between them grow enormous. There is no single height where anyone can point and say that the air ends completely. The transition from atmosphere to space happens gradually, like a mist that becomes increasingly faint as it drifts away from its source. An altitude of 100 kilometers is commonly known as the Kármán line and is used as a conventional boundary of space. This number is useful in aviation, law, and the classification of spaceflight. But it is not a visible line that can be seen from a spacecraft window. Extremely thin traces of gas continue above it, while atmospheric effects can extend to far greater altitudes. The boundary is clearer on a map than it is in the reality it represents. The layer closest to the surface is called the troposphere. Its height varies with location and season, but averages about 12 kilometers. Most clouds, rain, winds, and familiar weather phenomena occur within this layer. Nearly all atmospheric water vapor is also concentrated here, turning a remarkably thin region into the stage for weather across the entire planet. 12 kilometers can seem like a considerable distance in daily life. By road, it may cross many neighborhoods, and vertically, it reaches far beyond most places human beings can access without assistance. Yet compared with Earth's equatorial diameter of about 12,756 kilometers, the troposphere becomes almost impossibly small. The layer containing most clouds and rainfall occupies only a tiny fraction of the planet's size. If Earth were reduced to a sphere about 1 meter in diameter, the corresponding troposphere would be less than 1 millimeter thick. Within that narrow layer, storms unfold, winds move, clouds form, and most human activity takes place. Great cities, forests, farmland, and oceans all exchange heat and moisture with this air close to the surface. That scale makes it easier to understand why the blue line beyond the window appears so fragile. Above the troposphere lies the stratosphere, extending to an altitude of about 50 kilometers. The air there is far thinner. Ordinary clouds are almost entirely absent, and temperature changes follow a different pattern. Within this layer is a region rich in ozone, a form of oxygen molecule that absorbs most of the sun's harmful ultraviolet radiation. An invisible layer of gas performs the work of protecting life every day. Ozone does not block all ultraviolet radiation, but it greatly reduces the amount of dangerous energy reaching the surface. Without that absorption, damage to living cells would be far more severe. Plants, plankton, animals, and human beings all depend on this chemical protection taking place high above. From the ground, the process is completely silent and leaves almost no visible sign. Farther outward, the atmosphere is divided into layers with different densities, temperatures, and compositions. Some are regions where small meteoroids heat up as they descend, while others are associated with auroras, radio waves, and satellite orbits. Even so, most of the atmosphere's mass remains concentrated very close to the surface. About 99.99997% of its mass lies below an altitude of 100 kilometers. That number shows that nearly every gas molecule directly involved in daily life is concentrated within an extraordinarily thin layer surrounding a sphere of rock and water. Above it is not an endless ocean of air, but a gradual thinning toward vacuum. The sky feels vast because the observer stands inside it. Seen from the outside, its true proportions are impossible to ignore. That blue line does not contain oxygen alone. Near the surface, the atmosphere is composed mainly of nitrogen, followed by oxygen, with smaller amounts of argon, carbon dioxide, water vapor, and many other gases. The proportions among them help regulate temperature, the water cycle, and the conditions required for life. Even a small change in composition can have major consequences when it occurs globally and continues for long enough. The atmosphere also provides the pressure necessary for liquid water to remain stable on the surface. It carries heat from one region to another, softens the contrast between day and night, and distributes moisture through winds and clouds. Many small pieces of material from space are heated or broken apart as they pass through its layers. No single function can fully explain the atmosphere's importance. Its strength lies in the way all of these roles are connected. This protection is not like a rigid dome enclosing Earth. The atmosphere is constantly moving under the influence of sunlight, gravity, the oceans, and the surface below. It can produce a gentle breeze, but it can also gather energy into a powerful storm. The same layer of gas that sustains life is also the medium that carries heat, moisture, and changing weather into every region. From orbit, astronauts can see the structure of the atmosphere most clearly at sunrise and sunset. As light travels through a long path of air, different wavelengths are scattered in different ways, producing several bands of color. Blue usually lies closest to Earth's curve, while orange and yellow appear in lower layers of the transition zone. Those brilliant colors are actually the visible trace of an extraordinarily thin layer of gas. The scene is beautiful because light is revealing a structure that is normally invisible. At the same time, it can feel unsettling because above that glowing line, there is almost nothing left to protect the human body. A very small distance on the scale of the planet separates forests, cities, and oceans from an environment that cannot support life without a sealed spacecraft and life support systems. The difference between a place where humans can breathe and one where they cannot is contained within a very narrow band of color. Saying that the atmosphere is thin does not mean it is about to disappear or could be blown away from Earth in a single moment. Gravity holds most of the gas around the planet, and the atmosphere has existed and changed over billions of years. What matters is the scale of the environment suited to the human body. Compared with the size of Earth and the space surrounding it, that range is far narrower than ordinary intuition suggests. Fragility, then, does not mean absolute weakness. The atmosphere is resilient enough to sustain oceans, weather cycles, and life across immense spans of geological time. Yet it is also sensitive enough to respond to changes in heat, chemical composition, and activity on the surface. A system can endure for a very long time and still be vulnerable to disruption when internal conditions change faster than it can restore its balance. Living beneath the sky, people rarely think about the amount of air above them. Each breath comes so naturally that oxygen and atmospheric pressure are easily taken for granted. Only when the atmosphere is seen from the outside does that ordinary condition begin to look like a privilege of location. Beyond the blue layer, there is no second atmosphere waiting for humanity to enter. This realization is one reason many astronauts describe Earth with a mixture of love and concern. They do not simply see the place where they were born. They also see the physical boundary of the environment sustaining all known life. Every voice, every breath, every forest, and every ocean lies beneath the same layer of air. No one lives outside it, no matter how far apart their homes may be across the surface. A storm can cross several countries because the atmosphere does not follow the lines drawn on maps. Smoke, dust, and water vapor also travel with the winds, carrying their effects from one region to another. The air connects places that people often consider separate. Each region may have its own name, but all of them share the same atmospheric system. From space, the blue line does not change when the station passes over a political border. It does not become thicker above a wealthy nation or thinner above a region in conflict. That layer of gas surrounds mountains, oceans, cities, and deserts in one continuous motion. The planet's physical unity becomes more visible than any division recorded on the ground. When sunrise ends, the bands of color quickly dissolve into daylight. Oceans and clouds once again fill most of the window, while the atmosphere becomes more difficult to distinguish. Yet, once that thin rim has been seen, it is almost impossible to forget. Every landscape below is now understood to exist within a finite layer of protection. But the atmosphere is not the only thing that begins to look different from this height. While clouds, mountains, and coastlines remain clearly visible, one familiar feature found on nearly every map almost completely disappears. These are the borders that have shaped human history, power, and identity. From orbit, the planet offers no sign of where one country ends and another begins. From orbit, Earth still preserves many features large enough to recognize. Mountain ranges stretch across the surface like folds, great rivers curve through plains, and coastlines clearly separate land from ocean. Deserts, forests, and fields also form regions of different colors. Yet most of the familiar lines found on maps do not appear at all. A country may be shaded in its own color, enclosed by a bold outline, and labeled with an easily recognized name. Through a spacecraft window, all of those markings disappear. No glowing line crosses a plane to announce that one territory has ended. The planet simply continues through mountains, rivers, clouds, oceans, and layers of terrain flowing into one another. The difference between these two views comes from the purpose of a map. Maps help people organize space, define authority, structure societies, and find their way. They turn a complicated world into symbols that can be read. From orbit, those symbols are no longer printed on a page, and the true surface of Earth appears without the need for a legend. Natural boundaries remain visible because they are made of physical matter. A mountain range may rise thousands of meters, a river may extend across several climate zones, and an ocean may create an enormous distance between continents. These structures existed long before modern maps. They have shaped weather, migration routes, patterns of settlement, and the ways civilizations developed. Political borders belong to a different kind of reality. They matter because people collectively recognize them, defend them, and record them in law. Though invisible from space, they still directly affect the passports, languages, rights, responsibilities, and opportunities of billions of people. The fact that a border cannot be seen does not make it powerless in daily life. An astronaut may approach the window, hoping to find their homeland. At first, they search for a city, a river, or a coastline tied to personal memories. But the station moves too quickly, and the familiar stretch of land is far smaller than expected. Only a few minutes later, it has drifted out of view and given way to another region. The search often begins with a deeply personal question: where is my home down there? After many orbits, that question can expand into a different feeling. Home does not disappear, but it becomes one small part of a much larger picture. The meaning of home gradually extends beyond a city or a nation to include the entire planet. From that distance, the atmosphere does not change color as it crosses a border. Clouds do not stop to ask permission. Winds do not turn because of a line on a map, and rivers continue flowing according to the slope of the land. Natural systems move across territories without recognizing human divisions. The planet connects regions in ways deeper than any administrative boundary. A storm may form over the ocean, pass through several countries, and gradually weaken over another continent. Smoke from wildfires can travel thousands of kilometers on the wind, while desert dust can cross an ocean and settle over forests far from where it began. Water vapor rising in one place may become rain somewhere else. No region is completely separate from the rest of the system. The oceans reveal this connection most clearly. Warm and cold currents move through vast basins, carrying heat and influencing weather along distant coastlines. What happens in one body of water can spread elsewhere through currents, living organisms, and the chemistry of the sea. On maps, oceans often divide nations. Within the Earth system, they also connect them. At night, clusters of light make the human presence more visible. Cities, highways, and industrial areas form networks that can stretch across many regions. Yet, electric light usually reveals population density and levels of development more clearly than it reveals exact borders. A major city may shine brightly while nearby rural land nearly disappears into darkness. In a few unusual places, differences in infrastructure or land use may make a boundary easier to guess. One side may have more lights, another may follow a different agricultural pattern, or an illuminated road may create an unusual trace across the landscape. Even then, these are indirect signs of human activity, not natural divisions in the planet itself. Most of Earth carries no outlines like those printed on a map. Their absence leads many astronauts to reflect on the way human beings see the world. On the ground, national identity can feel deeply powerful because it is connected to history, family, language, and community. From orbit, those differences do not vanish from memory, but they are placed within a wider frame. Every country lies beneath the same atmosphere and travels around the same star. The sense of connection, then, does not have to begin as an abstract idea. It begins with a very specific observation. No part of the living planet exists apart from the rest. Air is shared, water circulates continuously, and the climate of every region is influenced by processes taking place elsewhere. Interdependence is not merely a moral message, it is a physical characteristic of Earth. Still, this perspective should not be turned into an overly simple conclusion. Seeing a planet without borders does not automatically end wars or resolve every disagreement. The causes of conflict remain rooted in history, resources, power, inequality, and collective memory. Distance only changes their scale within the observer's mind. A city under bombardment may leave no clear sign from orbit at the moment the station passes overhead. That does not make the suffering below smaller or less important. Every point of light still contains people with names, families, and memories of their own. A wider view must never erase the value of individual experience. This paradox gives depth to what astronauts feel. From far away, Earth appears unified and peaceful, even though they know that division, loss, and injustice continue beneath the clouds. The planet bears no visible marks of national borders, yet human lives are profoundly shaped by them. The stillness of the larger view exists beside turmoil that cannot be seen. Distance can also make problems that once seemed absolute appear smaller in physical size, but not smaller in meaning. A conflict may occupy only a narrow region of the surface, while its consequences for those who live there continue for generations. The orbital perspective does not deny this. It simply asks whether those divisions are worth allowing humanity to forget the greater whole that everyone shares. Some astronauts have described a sense of sadness when they realize how much energy people devote to defending borders that the planet itself does not display. That sadness does not come from denying history or identity. It arises because differences that matter so deeply to societies appear so small against the scale of Earth. From above, what is shared is always larger than what has been divided. Below the window, a river may begin in one country, cross another, and reach the sea in a third. Its water serves communities that may not share a language or a history. If one part of the river becomes polluted, the effects can continue moving downstream. Nature reminds us that interdependence remains even when people do not agree. Climate does not stop at checkpoints either. Carbon dioxide released in one region mixes into the shared atmosphere, while heat stored in the oceans can influence weather far away. From orbit, the unity of this system seems almost self-evident. Every society lives within the same thin shell of air, even though its decisions are made separately. The idea of one shared home does not require every culture to become the same. A home may contain many rooms, each with its own history, language, and way of life. What matters is that all of those rooms remain beneath the same roof, rest on the same foundation, and depend on the stability of the entire structure. Earth holds diversity within a single system in much the same way. From orbit, that diversity remains visible in the colors of the landscape, the shapes of cities, and the different patterns of land use. There is no perfectly uniform world, nor a surface entirely untouched by human activity. What disappears is only the illusion that each region can exist independently from the rest. Distance makes the larger connections easier to see. Astronauts still carry their nationality, language, and memories with them when they return. The view from space does not erase those layers of identity, but it can add another, broader one. They still belong to a particular place, while also recognizing that they belong to a finite planet. These two feelings do not cancel each other out. They exist together within a more complete understanding. After months in orbit, the image of an Earth without borders may become familiar to the eyes, but it rarely becomes ordinary in the mind. Each orbit carries the station across lands with different names, yet the window shows only the continuous flow of terrain and atmosphere. The divisions return when the observer looks at a map. Beyond the glass, they dissolve once more into the shared surface. That disappearance is not a rejection of the world humanity has built. It is a reminder that every political, economic, and cultural system exists upon a larger natural foundation. If that foundation is damaged, no border can keep everything on the other side completely safe. Earth does not choose where its effects will be felt according to the colors on a map. Even so, from the International Space Station, the planet is still too close and too large to be seen in its entirety at once. The window reveals only one section of the surface after another, while the curve of Earth always continues beyond the frame. To see the whole world as a solitary sphere suspended in darkness, human beings must travel much farther away. That distance lies where the moon moves around Earth. In December 1968, when most of humanity still knew the moon only through telescopes and unmanned photographs, the 3 astronauts of Apollo 8 left Earth orbit behind. Frank Borman, Jim Lovell, and Bill Anders did not land on the surface, but they traveled farther than any human beings before them. Their mission was to orbit the moon, test navigation systems, and prepare for the flights that would follow. Yet what would be remembered most clearly was not part of the technical mission plan. As the spacecraft moved farther away, Earth grew smaller with each passing hour. Continents lost their detail. Oceans blended into a deep blue, and clouds spread across the surface in thin white bands. The increasing distance compressed every familiar place into a single sphere. For the first time, human beings were not merely looking down on their home from above. They were seeing it as a complete object suspended in space. The average distance between Earth and the Moon is about 384,400 kilometers. Nearly 30 Earths could fit side by side across that empty span, even though many illustrations show the two worlds much closer together than they truly are. There are no stations or natural shelters along the way. Apollo 8 crossed that distance inside a small spacecraft, entirely dependent on systems built by human hands. As they approached the Moon, the landscape ahead began to change. Blue and white gave way to a gray, dry surface covered in craters. There were no oceans reflecting sunlight, no clouds in motion, and no atmosphere to soften the horizon. The moon appeared as a world preserving the scars of impacts accumulated over billions of years. On the 24th of December 1968, Apollo 8 entered orbit around the moon. The spacecraft passed repeatedly over the near side and then disappeared behind the far side, where communication with Earth was temporarily lost. During those minutes, the crew had only the sound of machinery inside the cabin and the silent gray surface below. Their home planet vanished from sight, even though it remained less than 400,000 kilometers away. The mission's most famous view appeared in a moment that had not been staged. As Apollo 8 tilted along its orbit, a blue and white sphere began to rise above the lunar horizon. Earth was not truly rising in the same way the sun rises from the ground, because the movement came mainly from the spacecraft traveling around the moon. Yet to the people inside the cabin, it looked as though an entire world were slowly emerging from behind the gray landscape. The crew's reaction was almost immediate. They did not begin with a formal observation, but hurried to find a camera and color film. Bill Anders was holding the camera as the blue sphere became more visible against the blackness. In only a few brief minutes, a practical decision about framing produced one of the most influential images of the 20th century. The photograph later became known as Earthrise. Across the lower part of the frame lies the moon's dry gray horizon. Above it hangs a small Earth, glowing with the blue of its oceans, the white of its clouds, and the muted brown of its continents. Surrounding both worlds is not a blue sky, but darkness without any visible end. The contrast makes it immediately clear which world holds water, an atmosphere, and life. Earth had been photographed from space before Apollo 8, so the power of Earthrise does not come from being the first image in an absolute sense. What made it different was the viewpoint and the contrast contained within a single frame. A colorful world appeared above a surface almost entirely devoid of biological signs. The distance was great enough to make Earth seem small, yet still close enough for oceans and clouds to remain visible. On a globe resting on a desk, Earth occupies the center of attention. A person can turn it, find their country, and read the names of the oceans. Maps also place the planet's surface at the center, while everything beyond it is usually reduced to the edge of the page. Earthrise broke that arrangement by placing Earth inside a space vastly larger than the planet itself. The lunar surface in the foreground is just as important as the blue sphere in the distance. Its grayness makes Earth's blue and white colors appear more vivid, while its emptiness gives the planet's clouds an entirely different meaning. No rivers flow through the craters, no winds lift dust into clouds, and no oceans store heat. The moon's silence makes the home planet seem even wetter, more active, and more alive. For the three astronauts, that sphere was not an abstract symbol. Their families, colleagues, hometowns, and every place they had ever known were contained within that small area of light. No one lived outside that scene, watching them from another home. Apollo 8 was a lonely point between two worlds, while all of civilization remained on a single planet in the distance. That sense of isolation did not mean Earth was completely unprotected. The planet has an atmosphere, a magnetic field, oceans, and many systems that have sustained life across immense spans of time. Yet Earthrise showed that those conditions do not extend endlessly into space. They are concentrated around one small sphere, enclosed by darkness that is almost entirely empty. When people on the ground look at the photograph, they know they are standing somewhere inside that blue globe. For the Apollo 8 crew, the truth was experienced in reverse. They were outside it. For several days, distance separated them from every city, forest, and ocean. From that position, home was no longer a point on a map. It was the entire planet. Earthrise also changed the sense of scale. On the surface, an ocean may seem too vast to cross. A mountain range may fill the horizon, and a city may contain millions of people. In the photograph, all of those scales are compressed into tiny details on a sphere hanging in darkness. What once seemed endless suddenly has a visible boundary. But Earth appearing small did not make anything on it less important. Instead, its limits made every part of the planet feel more valuable. A forest became one component of the only living system visible. while an ocean was no longer merely the distance between continents. The blue of water became a rare sign amid the cold, dry landscape surrounding it. Once the viewer recognizes the blue sphere as home, the rest of the emotion almost seems to arise on its own. Every history, joy, loss, and hope of humanity exists within that small frame. The darkness around it is not decorative space added to emphasize the subject, but a real environment so vast that its scale is almost impossible to imagine. Earthrise, therefore, creates both a feeling of intimacy and a distance unlike anything experienced before. Even so, this was not yet the most distant view of Earth. From the distance of the moon, the planet remained large enough for clouds, oceans, and parts of continents to be seen. It was still bright, colorful, and unmistakably the central subject. Farther away, those details would continue to disappear until the entire world became only a point of light. As Apollo 8 continued around the moon, Earth slipped from the window once again and vanished behind the gray horizon. The moment the blue sphere disappeared, the cabin felt more isolated, even though the planet had not moved from its place. Between the two worlds lay a region of space with no natural conditions suited to the human body. Every breath inside the cabin depended on small machines functioning exactly as intended. From the distance of the moon, the blackness surrounding Earth no longer seemed like a background designed to make the planet stand out. It was the actual environment filling most of the solar system and almost all of the universe. The blue sphere occupied only a small part of that view, while life itself was concentrated within an even thinner layer near its surface. The beauty of Earthrise therefore carries a colder realization with it. Beyond this home, there is no second home nearby. Beyond Earth's blue curve, darkness begins almost immediately. It is nothing like night on the ground, where the sky still contains air, moisture, and scattered light. Here, blackness is not a sign of the time of day, but the natural condition of space itself. Even while the sun is shining, the emptiness behind everything remains so deep and dark that its limits are impossible to define. On Earth, people often look upward and imagine the universe somewhere above their heads. That way of thinking is shaped by gravity, the horizon, and the habit of living on a solid surface. Once they leave the planet, those familiar directions gradually lose their meaning, and space is no longer a dome surrounding the world. Astronauts realize that they have entered the very environment they once observed from far below. The space between planets is nearly a vacuum, but it is not completely empty. It still contains extremely sparse gas particles, tiny grains of dust, electromagnetic radiation, and charged particles moving at high energies. The density of matter is far too low to provide enough air for even a single breath. Compared with the atmosphere near Earth's surface, it is an environment with almost no pressure at all. The human body evolved to function under very specific conditions. The lungs need suitable pressure to exchange gases, the blood must remain stable, and soft tissues depend on the surrounding environment to avoid injury. Outside a spacecraft or protective suit, those conditions disappear. Space does not actively attack the human body. It simply provides none of the things the body needs to remain alive. The lack of oxygen is only part of the problem. When external pressure falls too low, fluids in the body can begin behaving in ways they never would on the ground. A person would not explode as some movies suggest, but they would quickly lose consciousness from oxygen deprivation and face severe injury. Survival would depend on restoring pressure and breathable air within a very short period of time. For this reason, a spacecraft is more than a means of transportation. It is a small piece of Earth carried through the vacuum, complete with air, pressure, temperature control, water, and systems that remove carbon dioxide. Every layer of the hull, every valve, and every pipe helps preserve the artificial environment inside. Only a few centimeters of material may separate a habitable cabin from a surrounding emptiness entirely unsuited to the human body. Sunlight in space can be stronger and more direct than it feels on Earth's surface. With no clouds or thick atmosphere to soften it, surfaces facing the sun can receive intense amounts of energy, yet the sky around them remains black. Light becomes visible only when it travels directly into the eye, or reflects from an object such as a spacecraft, the moon, or Earth. The sky on the ground appears blue because sunlight interacts with molecules in the atmosphere. Shorter wavelengths are scattered more strongly, spreading blue light across the entire field of view, even when the observer is not looking directly toward the sunday. In space, the density of molecules is far too low to produce the same effect. The result is a scene where brilliant light and profound darkness exist side by side. That contrast makes the emptiness feel even more apparent. One side of a spacecraft may shine intensely in sunlight, while behind it lies almost absolute blackness. There is no gentle transition like twilight within an atmosphere. Light does not transform the darkness into a sky because there is no medium to scatter it in every direction. Temperature in space is not simply a matter of cold. In a vacuum, heat cannot be carried through air because there is almost no air available to transfer energy. An object exposed to sunlight may become extremely hot, while a section in shadow can cool in a very different way. Spacecraft must regulate temperature through insulation, shields, heaters, and radiator systems. The human body cannot regulate itself under these conditions without protection. A spacesuit maintains pressure, supplies oxygen, removes carbon dioxide, and controls the temperature around the astronaut. It functions like a miniature spacecraft shaped around the body. Each time an astronaut leaves the cabin, they carry an individual living environment with them into the emptiness. Beyond vacuum and temperature, radiation presents a danger that cannot easily be detected by the senses. On the ground, the atmosphere and magnetic field significantly reduce the number of high-energy particles reaching the surface. Outside those protective layers, human beings are exposed to more radiation from the sun and distant sources throughout the galaxy. No color or sound gives warning when a high-energy particle passes through material. The sun continuously releases a stream of charged particles known as the solar wind. During periods of intense activity, eruptions can send large amounts of high-energy material into space. On Earth, the magnetosphere deflects much of this material or guides it toward the polar regions. For a spacecraft farther away, these events can increase radiation levels and force the crew to move into a more heavily shielded area. Galactic cosmic radiation comes from beyond the solar system and includes particles traveling close to the speed of light. They can penetrate deeply into a spacecraft and produce secondary particles when they collide with its materials. Complete protection against this radiation is extremely difficult because it would require a great deal of shielding mass. The longer the journey lasts, the more important the accumulated dose becomes. Space also contains dust and small fragments of matter traveling at high speeds. Most are extremely small, but velocity means that even a tiny particle can cause damage on impact. Spacecraft use multiple layers of material to break apart, slow down, and disperse the energy of these fragments. A hazard does not need to take the form of a massive asteroid to become significant. Distance creates another kind of risk, quieter than any collision. In low Earth orbit, astronauts remain relatively close to the planet and may be able to return within a short time if conditions allow. As a mission travels toward the moon or beyond, the possibility of direct assistance decreases sharply. A minor failure can become serious simply because there is nowhere nearby to land or obtain replacement parts. Even the space between Earth and the moon is an empty region nearly 400,000 kilometers wide. The distance to Mars varies enormously and is often measured in tens or hundreds of millions of kilometers. Radio signals require several minutes to travel one way, making immediate guidance impossible. The crew must be able to assess and solve problems on their own without waiting for an instant response. These distances help explain why the darkness outside a spacecraft window feels different from the night sky. Standing beneath the stars, a person is still surrounded by air, land, water, and billions of other people. From a small spacecraft in deep space, the darkness becomes a real distance that must be crossed. It is no longer a distant landscape, but the environment directly surrounding the crew. Astronaut Christina Koch has described the realization that all of humanity is sustained within Earth's remarkably thin atmospheric boundary. Beyond that glowing line, almost everything is unsuitable for the human body without life support systems. This awareness does not necessarily create panic. More often, it arrives as a deeper silence before something that has always been present but is rarely seen so clearly. The fear, then, does not come from a mysterious object moving closer. There is no sign that a specific cosmic disaster is waiting just outside the window. What feels unsettling is the contrast between the vastness of the uninhabitable environment and the very narrow region where life exists. The entire familiar world is concentrated on a single sphere within an immense emptiness. The universe does contain phenomena far more powerful than anything experienced on Earth. Stars can explode, black holes can distort space-time, and enormous bursts of energy occur across unimaginable distances. Yet, most of these are not direct threats to everyday life. Understanding the power of the universe does not require concluding that the end of the world is near. Scientific awe is different from fear created through exaggeration. It begins when human beings recognize scales far beyond intuition while also understanding the limits of their own bodies. A creature that depends on stable temperatures, liquid water, and breathable air is looking out into a universe where most places offer none of those conditions. That quiet fact alone is enough to create profound emotion. On Earth's surface, nature can sometimes seem severe, but even a frozen desert or a high mountain peak remains within the atmosphere. Human beings can carry water, clothing, and equipment to survive there for a limited time. In space, there is no natural foundation supporting the body in the same way. Every condition required for life must be created, controlled, and maintained artificially. This makes Earth appear not only as the place where humanity was born, but as a planetary-scale life support system. Air circulates naturally, water moves through continuous cycles, land and oceans help regulate temperature, and living organisms contribute to many chemical processes. These functions are often treated as background because they operate so steadily. Only from the outside does the value of the entire system become fully apparent. The darkness also makes the planet's colors feel different. The blue of water, the white of clouds, and the brown of land do more than create a beautiful image. They are signs of matter, motion, and conditions that do not exist in the surrounding emptiness in the same way. Each color reflects one part of the environment sustaining life on the surface. For this reason, fear can exist beside peace without contradiction. Astronauts can be overwhelmed by Earth's beauty while understanding that this beauty is concentrated within a very limited space. The blackness does not threaten through intention. It simply reveals how different the planet truly is. Earth's isolation becomes clearest when no nearby world displays the same vivid blue of life. Yet the planet is not suspended completely unprotected within that environment. Alongside the visible atmosphere, Earth is also supported by its magnetic field, the ozone layer, the oceans, and many other natural mechanisms. Some forms of protection appear as light, while others are known only through their effects. To understand how life can endure within the darkness, we must look toward the invisible shields operating around the planet. Earth's first protective layer is also the easiest to see from space. When sunlight passes through the planet's edge, the atmosphere appears as a thin blue band wrapped around the oceans, continents, and clouds. That glowing line is not a solid dome, but it separates a breathable world from an environment that is almost entirely uninhabitable. Most human life unfolds beneath this layer of gas, which seems nearly endless when viewed from the ground. The atmosphere provides oxygen, maintains the pressure needed for liquid water, and carries moisture through moving currents of air. It also helps soften the difference between daytime and nighttime temperatures by redistributing and retaining part of the planet's energy. Clouds reflect sunlight, while gases in the air slow the loss of heat from the surface. As a result, Earth does not heat up and cool down as abruptly as many worlds with little or no atmosphere. This layer of gas also slows down and breaks apart many small fragments of material falling in from space. As they enter at high speed, they heat up, begin to glow, and often disintegrate before reaching the ground. Brief streaks of meteors are signs of this process, not stars falling from the sky. The atmosphere cannot stop every object, but it greatly reduces the number of small impacts the surface must endure. Above the layers where ordinary clouds form lies the ozone region of the stratosphere. Ozone molecules absorb most of the sun's harmful ultraviolet radiation before it reaches the ground, reducing damage to living cells. This layer does not eliminate ultraviolet radiation entirely, but lowers its intensity to levels that life has been able to adapt to over long periods. A very small component of the atmosphere protects plants, plankton, animals, and human beings every day. Beyond the atmosphere lies another shield, one with no clearly visible color. The The movement of electrically conductive material deep within Earth's core helps generate a magnetic field around the planet, creating a region of space known as the magnetosphere. It extends far beyond the surface and constantly interacts with the stream of charged particles flowing outward from the Sun. This stream is called the solar wind, though it is entirely different from wind in the atmosphere. When charged particles encounter the magnetosphere, most are deflected or guided around the planet. This shield does not block every form of radiation, but it reduces the amount of solar material that can directly affect the atmosphere and surface. The side facing the sun is compressed, while the opposite side stretches into a long tail through space. It behaves more like a flexible buffer than an unmoving wall. Some particles still travel along magnetic field lines toward the polar regions, creating auroras when they collide with the atmosphere. Those ribbons of green, red, or violet light reveal that the shield is not completely sealed. During powerful solar storms, satellites, radio communications, navigation systems, and electrical grids can still be affected. Protection always exists alongside clear physical limits. Life does not depend on a single shield, but on many systems working together. The oceans absorb, store, and transport enormous amounts of heat through currents that span the planet. Because water warms and cools more slowly than land, it helps reduce extreme temperature changes. The blue seen from space is therefore also the visible sign of a planetary-scale climate regulator. Water evaporates from the ocean, forms clouds, returns as rain or snow, and then moves through rivers, soil, and groundwater. This cycle carries moisture from one place to another while distributing energy across vast distances. Rain falling far inland may begin as water that once rested in a distant ocean. Regions that seem separate remain connected through the continuous movement of water. Earth's distance from the sun helps liquid water remain on the surface over long periods. The planet receives enough energy to keep its oceans from freezing completely, but it is not so close that all of its water rapidly evaporates. Yet being at a suitable distance is only part of the story. Pressure, atmospheric composition, chemistry, geology, and a long planetary history have all helped determine the conditions that exist today. Calling Earth a perfect planet would erase much of that complexity. This world has endured major impacts, volcanic eruptions, climate shifts, and repeated mass extinctions. What is remarkable is its ability to preserve environments suitable for life through billions of years of change. Energy from the sun, abundant water, a sufficiently thick atmosphere, and geological activity have worked together to create that foundation. No single factor can create a living world on its own. Time allowed cycles to form, change, and settle into new states, while living organisms gradually became part of the system itself. Plants and other photosynthetic life helped maintain oxygen, forests influenced the water cycle, and microorganisms took part in essential chemical cycles. Life depends on the planet, while also transforming the environment it inhabits. So far, Earth remains the only place confirmed to support life. Astronomers have discovered thousands of planets orbiting other stars, including some with intriguing estimated sizes or temperatures. Yet being located in a region where liquid water might exist does not guarantee the presence of oceans or living organisms. A vast distance still separates an appealing possibility from scientific evidence. No other planet has been confirmed to harbor life, and no known world is close enough to serve as a replacement home. Many potential destinations lie tens or hundreds of light years away, far beyond our present ability to travel. Telescopes may reveal some of their characteristics, but they cannot turn those worlds into practical shelters. Earth, therefore, remains the only living environment humanity currently possesses. The planet's value lies in more than its beauty when seen from space. It is the only place we know with breathable air, accessible water, and ecosystems complex enough to sustain human life. Even the International Space Station must recycle water, regulate its air, control temperature, and receive supplies from the ground. No spacecraft can recreate an entire living world inside a sealed cabin. A single breath depends on the atmosphere and on the activity of living organisms across immense spans of time. A glass of water is connected to oceans, clouds, rain, rivers, and the layers of soil that hold moisture. A comfortable temperature ultimately depends on how the planet receives, stores, and distributes energy from the sun. The most familiar parts of life are all the result of many systems operating at once. Resilient as they are, these protective systems do not allow humanity to ignore every consequence. The atmosphere can absorb and disperse many disturbances, but it cannot take in unlimited pollution or excess heat without changing. The oceans store vast amounts of heat, yet this also allows their effects to persist for many years. A system that has survived for billions of years can still move away from conditions favorable to human life when the pressure becomes strong enough. Fragility, then, is not the opposite of resilience. The planet can continue to exist, even when the habitats of many species are profoundly altered. What must be preserved is not merely the mass of rock orbiting the sun, but the rare combination of conditions that allows water, climate, and life to exist together. That realization transforms fear of the darkness into a clearer sense of gratitude. From a spacecraft window, most of Earth's protective mechanisms still cannot be seen directly. The observer sees only the atmosphere, clouds, oceans, and sometimes the aurora, while the magnetic field, ocean currents, and chemical cycles continue their quiet work. Earth is not protected by a single miracle, but by many conditions sustained together over immense spans of time. It is this cooperation that keeps the familiar world alive within the emptiness. Yet, even from the distance of the moon, the planet remains large enough for clouds, oceans, and parts of continents to be recognized. The sense of smallness has begun, but it has not reached its final limit. To see the whole of human history reduced to a point almost too faint to notice, one must travel thousands of times farther away. That view appeared only when a spacecraft reached the outer edge of the solar system and turned its camera back toward home. On the 14th of February 1990, Voyager 1 was already far beyond the worlds it had once visited. The spacecraft was no longer heading toward a new planet, but continuing outward from the central region of the solar system. Behind it lay Jupiter, Saturn, and years of completed exploration. Ahead was only a long journey into an expanse larger than any map humanity had ever drawn. Voyager 1 was launched in 1977 on a mission to study the outer giant planets. After flying past Jupiter and Saturn, the spacecraft continued operating, carrying instruments that had worked in cold, darkness, and at an ever-growing distance from Earth. Every signal it sent home had to cross a greater distance than the one before. Yet, in early 1990, the mission team wanted the spacecraft to perform a task that was not intended to discover another world. The idea of turning the camera back toward the solar system had long been promoted by Carl Sagan and several members of the Voyager team. The goal was not to collect unknown geological details, because from that distance, every planet would be far too small. What they wanted was a portrait that revealed Earth's place within a much larger expanse. An image with almost no scientific value as a measurement could still carry profound meaning for the way human beings understood themselves. To accomplish this, Voyager 1 had to rotate its camera toward the planets it was leaving behind. The sun remained such a powerful source of light that photographing in its direction required careful planning to avoid damaging the instruments. The spacecraft captured a sequence of 60 images, creating what became known as the Solar System Family Portrait. Several planets appeared in the series, although some worlds could not be photographed clearly because of their position, lighting, or distance. When the camera turned toward Earth, Voyager 1 was about 6 billion kilometers from the Sunday. This distance was so vast that light, although it travels faster than anything else in nature, still required several hours to cross it. From that position, the sun no longer occupied a large region of the sky, yet it remained overwhelmingly brighter than everything around it. Earth was only an extremely small point located near the direction of that light. In the image that later became famous, our planet appears within a faint ray produced by sunlight scattering through the camera's optical system. Earth is so small that it occupies only about 1 pixel, barely enough to possess any recognizable shape. There is no visible curve, no blue ocean, and none of the familiar white bands of cloud. The entire world has been reduced to a tiny point of light against the darkness. Without being told where to look, a viewer could easily miss it. It does not stand out like Earthrise, where the planet still appears in clear color above the lunar surface. nor does it resemble global images taken from much closer distances, where continents, storms, and oceans remain rich in detail. The pale blue dot almost forces the viewer to search for their own planet within the frame. What feels so strange is the contrast between the image and the reality it contains. The point of light appears almost meaningless to the eye, yet within it, billions of people are living, working, loving, and arguing. Crowded cities leave no recognizable trace. Every ocean, mountain range, and forest has been compressed into the same faint amount of light. There is no way to see which countries are wealthier or poorer. No distinction can be made between a capital city and a village, a palace and a small home, or a place at peace and a region in conflict. No flags, borders, or names emerge from that distance. The differences that govern life on the ground disappear entirely from the photograph. Nor is there any direct trace of the empires that once existed. Civilizations that built cities, expanded their territories, and eventually vanished all occupy the same point of light as the societies of the present. Thousands of years of history are compressed into a space smaller than a grain of dust within the frame. Human time suddenly seems brief when placed beside the journey of light and the scale of the solar system. Even events shaking the entire world at the moment the photograph was taken could leave no visible sign. A crisis might dominate the news, yet it could not change the appearance of the point. A dispute might consume the thoughts of millions of people, while from Voyager 1, it did not exist as a visual detail. Distance does not erase consequences, but it changes their scale within the mind. The image data did not appear immediately on a screen on Earth after the camera finished its work. Voyager 1 had to store the information, transmit it piece by piece through an extremely weak radio signal, and aim its antenna precisely toward receiving stations billions of kilometers away. Each bit of data traveled through space for hours before reaching the antennas of the deep space network. Receiving the complete sequence required many separate communication sessions. It was not until the 1st of May 1990 that the final data from the image series had been fully received. For weeks, the image of Earth existed as a signal traveling through the emptiness, like a message sent from the distant edge of the solar system. No human being stood beside Voyager 1 to look back through the camera. The spacecraft carried out the command sent from the very point of light it was attempting to photograph. The image does not show Earth in the way people usually expect. It does not display the brilliant beauty of a blue planet, nor does it contain much detail for scientific study. That absence is precisely what gives the photograph its power. When nearly everything has been removed, what remains is the true scale between the human world and the space surrounding it. Earthrise showed Earth as a colorful oasis above the gray horizon of the moon. The pale blue dot went farther by making that entire oasis almost disappear. The distance of the moon was enough to reveal the planet's isolation, but Voyager 1's position made that isolation feel nearly absolute. There was no foreground landscape left for comparison, only darkness and a point of light that was difficult to see. Yet, smallness does not mean insignificance. An object may occupy almost no space within an image and still contain everything the observer considers valuable. If every family, memory, language, work of art, and chapter of history exists upon that point, then size cannot determine its importance. On the contrary, its finite nature makes that importance even clearer. Everything human beings have ever loved has existed on Earth. Every piece of music ever composed, every story ever told, and every discovery that changed humanity's understanding began within that tiny space. Generations not yet born will also depend on the same oceans, atmosphere, and soil contained within that point of light. No part of human life exists outside it. The photograph also weakens the sense that the planet is an endless source of resources. From the surface, oceans can stretch all the way to the horizon, and continents can be vast enough that many generations never cross them entirely. From a distance of 6 billion kilometers, all of those resources exist within a single point of light. No second reserve appears nearby to replace what has been depleted. The meaning of the pale blue dot is not to make humanity feel insignificant or powerless. It offers a perspective in which humility can exist alongside responsibility. Once we recognize that every society shares the same planet, treating one another with greater kindness is no longer merely a private moral choice. It is also a rational response to the fact that no one lives on a world completely separate from everyone else. Protecting Earth does not mean preserving the planet unchanged like a motionless exhibit. This world has always been transformed by climate, geology, and life. What humanity can do is avoid pushing the systems that sustain us toward more extreme conditions. The pale blue dot reminds us that the planet may continue turning even if the conditions supporting human beings and many other species deteriorate severely. In the photograph, Earth lies within a beam of light that makes it appear almost more fragile than it truly is. That beam is only an optical effect, not a special column of light protecting the planet. Yet the coincidence created an unforgettable image, the entire world resting on a glowing speck of dust within the darkness. Science can explain the origin of the beam without diminishing the emotional power it creates. Voyager 1 could not see the people waiting for its data to return, nor could it understand the meaning the photograph would carry through the decades that followed. The spacecraft simply followed a sequence of commands, turned its camera, recorded the light, and continued on its journey. Meaning emerged when human beings looked at the data and recognized themselves within a point that seemed to have almost no size at all. After the image sequence was completed, Voyager 1's camera was turned off to conserve power and resources for its other instruments. The spacecraft would never take another family portrait of the solar system. The pale blue dot was therefore both a final glance backward and a visual farewell to the planets left behind. From then on, Voyager continued outward as Earth grew smaller with distance. From the spacecraft's current position, the planet is even more difficult to distinguish than it was in 1990. The distance continues to increase, the signal grows weaker, and every command takes longer to arrive. Yet the point of light in the photograph does not lose its meaning simply because Voyager has traveled farther. It still preserves the moment when humanity first saw its entire history almost disappear into space. The feeling created by the image rarely arrives as a sudden shock. It develops slowly, once the viewer understands that the tiny point is Earth and begins placing every part of life inside it. A room, a city, a lifetime, and an entire civilization must all fit within the same point. The silence people often feel before the photograph is the mind responding to a change in scale that has happened too quickly. Even so, the pale blue dot is only light captured by a camera from a great distance. The person viewing it on Earth is still sitting in a room filled with air, gravity, and familiar sounds. For astronauts, the shift in perspective does not come from a single image, but repeats every time they look through the window. For days or months, they directly witness Earth surrounded by darkness and gradually come to understand their own position in a different way. A photograph may make someone reflect for a few minutes before returning to everyday life. But what happens when that view becomes part of every day, when the thin atmosphere appears again and again, and the entire world is always below? That question leads to an experience described by many space travelers, yet one that remains difficult to measure fully. It is known as the overview effect. The overview effect does not begin at one precise, identifiable moment. For some astronauts, it appears the first time they see the curve of Earth through a window. Others need several days of watching oceans, continents, and the atmosphere drift below. The change often happens quietly, as a familiar image gradually takes on an entirely different meaning. The term overview effect was popularized by writer Frank White in a book published in 1987. After speaking with many people who had traveled into space, he noticed that they often described a shift in how they viewed Earth and humanity's place within it. Their accounts were not exactly the same, but all emerged from the experience of observing the planet from the outside. Frank White gave a shared name to this distinctive group of perceptions and emotions. The overview effect is not an illness, a syndrome, or an abnormal psychological state, nor has it been identified through a single biological marker that can be measured in the brain or body. It is primarily a concept describing a transformation in perception, emotion, and the way a person evaluates the world. Most of what science currently knows about it comes from personal accounts, interviews, and studies involving a very small group of people. The number of people who have seen Earth directly from space remains tiny compared with the global population. Even within that small group, viewing conditions have varied considerably. Some traveled for only a few days. Others lived for months aboard an orbital station. while the Apollo astronauts journeyed as far as the moon. For this reason, it is difficult to turn the experience into a universal response that applies to everyone. The most frequently described element is a sense of awe. From low Earth orbit, the planet is large enough to fill nearly the entire window, yet from the moon, it is small enough to fit within a single frame. The human mind is accustomed to judging the world through the scale of a room, a road, or the city nearby. When that scale changes suddenly, ordinary comparisons are no longer enough to describe what is being seen. The awe comes not only from size, but also from an unexpected kind of beauty. Clouds form white bands that continually shift, light moves across the oceans, and sunrise appears as a very thin ribbon of color around the planet. None of these scenes are arranged, yet they still create a sense of balance and unity. The observer knows that countless complex movements are unfolding below, while the complete view appears almost perfectly still. This emotion can temporarily draw attention away from the self. Personal worries do not disappear, but they are placed beside something far greater. The mind must expand to hold the individual, the planet, and the surrounding emptiness all at once. Some researchers describe this as a self-transcendent state, in which the boundary between personal concerns and the wider world becomes less absolute. This does not mean that a person loses their identity or stops caring about their own life. Astronauts still remember their families, work, responsibilities, and places of birth. What changes is the scale of those concerns in relation to the entire picture. A problem may remain important, but it no longer occupies the whole field of awareness as it once did. Alongside awe often comes a sense of becoming smaller. From orbit, no individual person can be seen, even though billions are living below. From greater distances, even cities and continents gradually lose their detail. Realizing that one person is only a very small part of the planet can create humility, but it does not necessarily lead to a sense of meaninglessness. In many accounts, feeling small actually increases the value of life. A human being may occupy almost no physical space, but that does not make their love, memories, or responsibilities any less real. Physical size and meaning do not follow the same scale. A planet that nearly disappears in Voyager's photograph still contains the entire known history of life. A second common element is an awareness of fragility. From the ground, the atmosphere appears so vast that its limits cannot be seen. Through a spacecraft window, it is reduced to a thin blue line between the surface and the darkness. Even without knowing every scientific measurement, an observer can sense that the living environment exists only within a finite range. This fragility should not be taken to mean that Earth could easily shatter or disappear. The planet has endured billions of years of change and will continue to exist through many transformations in the future. What is more vulnerable are the conditions that support societies, ecosystems, and human health. From space, the distinction between protecting the planet itself and protecting its habitability becomes much clearer. Another element is a feeling of connection. From orbit, most political borders cannot be seen, while clouds, rivers, and oceans continually cross from one territory into another. Natural systems do not operate according to the divisions shown on maps. This observation can expand the idea of community beyond a city, a nation, or a familiar group of people. Yet this sense of connection does not erase every difference. Culture, history, language, and identity still hold profound value in human life. The overview effect does not require people to abandon those things in favor of a single identity. Instead, it may add another layer of awareness, one in which diversity exists within a shared home. Some astronauts return with a stronger desire to speak about the environment or international cooperation. Others focus on education, science, or sharing images of Earth with the public. Even so, spaceflight should not be assumed to produce one specific course of action in every person. A powerful emotion may open the door to new ideas, but how each individual turns those ideas into action depends on their own circumstances. Not every astronaut is moved to tears at the window. Some feel peaceful, others overwhelmed, while some observe the scene with the focused attention of a scientist or mission specialist. An important experience does not always produce an intense outward reaction. The change may only become visible months later. after they have returned home and begun reflecting on the journey. There is also no evidence that everyone returns from space sharing the same political, religious, or ethical views. Two astronauts may look at the same planet and interpret their emotions through entirely different systems of belief. One may perceive unity, while another focuses on personal responsibility or the beauty of nature. The overview effect does not erase the psychological history each person carries with them before the flight. The viewing distance may also change the nature of the experience. From the International Space Station, Earth remains very close, filling most of the field of view and continually revealing new details. Astronauts can recognize coastlines, storms, city lights, and sometimes the region they call home. From this perspective, the strongest impression is often the planet's movement, interconnectedness, and vitality. From the distance of the Moon, the entire Earth can fit within a single window. The observer no longer feels as though they are flying over one region after another, but rather looking at the whole world as a solitary object. The cold gray surface of the Moon and the surrounding darkness make the planet's blue color stand out even more. The sense of isolation can therefore be stronger than it is from low Earth orbit. The amount of time spent observing also makes a difference. A short flight may bring an initial shock of scale, while months in orbit allow the image to become deeply woven into everyday life. Astronauts work, eat, and talk while Earth continuously drifts beyond the window. What begins as a rare moment gradually becomes part of the foundation for how they understand where they belong. Psychologists often connect the overview effect with the feeling of awe inspired by something immense. When people encounter a scene that exceeds their familiar mental patterns, the mind must adjust the way it organizes information. They do not simply add a new image to memory, but may have to reshape their entire understanding of their place in the world. This process helps explain why the experience can feel both captivating and unsettling. Beauty creates attachment because the observer recognizes the planet as the place containing everything familiar. The blue of the water, the clouds, and the lights of cities make Earth appear vividly alive within a harsh environment. The more beautiful the world appears, the stronger the desire to protect it may become. Yet that same attachment can make the awareness of danger more difficult to bear. Smallness creates another kind of unease. When Earth fits entirely within the darkness, the illusion that the world extends forever, or that there will always be more space to replace what has been lost, begins to disappear. Every forest, ocean, and city exists within a limited area. What once seemed like an endless supply of resources is revealed as part of a closed sphere. The blackness surrounding Earth emphasizes its isolation without requiring images of catastrophe. There is no second Earth nearby where humanity could easily relocate. The Moon has no oceans or breathable air, while the other planets are distant and hostile. The fear comes from the absence of a replacement, not from some mysterious object drawing closer. The thin line of the atmosphere deepens that feeling. Every breath, forest, cloud, and weather system exists beneath a layer of gas that seems almost insignificant compared with the planet's diameter. From space, air is no longer something that can be taken for granted. It becomes a precious condition shared by every living organism on the surface. The absence of visible borders weakens the familiar sense of division, but it can also create a quiet sadness. Human beings devote enormous energy to defending or contesting lines that the planet itself does not display. Those boundaries still carry social meaning, yet they cannot change the fact that every region shares the same atmosphere and oceans. Distance makes what is shared occupy more of the view. All of these emotions can exist at the same time without canceling one another out. An astronaut may feel peaceful before Earth's beauty, anxious about its fragility, and grateful to belong to it. Ordinary language often asks us to choose one clear emotion, while the real experience is far more complex. The overview effect is therefore difficult to describe using only words such as happiness, sadness, or fear. Nor is it a state that remains at the same intensity forever. Astronauts still have to leave the window, inspect equipment, exercise, conduct experiments, and manage highly specific tasks. Profound emotions exist alongside an ordinary schedule inside a confined space. This constant alternation allows the experience to remain connected to reality and gradually become part of the way they think. When the mission ends, the view beyond the window is no longer present every day. Earth once again becomes the ground beneath their feet, the horizon appears flat, and the sky fills their entire field of vision. Personal concerns and familiar routines quickly return. Yet, someone who has seen the planet from the outside can never completely erase the memory of that scale. The final challenge, then, is not finding the right words to describe Earth from space. It is learning how to bring that vast perspective back into a life made of small daily choices. An experience may transform awareness, but its lasting value appears only when that awareness finds a place in action. After seeing the whole of home, an astronaut must learn how to live within it again. As the spacecraft begins to re-enter the atmosphere, Earth is no longer a blue sphere beyond the window. It becomes a surface approaching at tremendous speed, obscured by the intense glow of heat surrounding the vehicle. Drag increases, the cabin shakes violently, and the weightlessness that lasted for months gradually comes to an end. The planet begins pulling the human body back into the familiar sensation of weight. In orbit, an arm can drift upward with only the slightest movement, and the body does not have to support its own mass. When gravity is felt again, the head, shoulders, and legs suddenly seem heavier than expected. Sitting upright, turning, or maintaining balance may require concentration. Actions that were once entirely natural must be relearned over a short period of time. After the capsule touches down on land or water, the hatch opens and outside air flows in. Astronauts once again hear the wind and feel temperature, along with the scent of soil, plants, or salt water in ways that do not exist inside the sealed environment of a spacecraft. The sky fills their entire field of vision again instead of being compressed into a thin rim around the planet. Earth is no longer below them. It surrounds them once more in every direction. Returning home is more than a change in gravity. After months of watching continents follow one another beneath the spacecraft, astronauts step back into a world divided into streets, buildings, schedules, and highly specific responsibilities. They must read messages, answer calls, move through traffic, and readjust to the rhythm of life among millions of other people. The planetary view is quickly replaced by countless details at close range. From an orbital window, a city is only a patch of light on the dark side of a continent. Back on the ground, that same city has car horns, lines of people waiting, bills that must be paid, and conversations that could never be seen from space. Problems that disappeared within the larger view immediately regain their full scale in daily life. The overview effect does not allow anyone to escape those ordinary realities. Yet the memory of Earth seen from the outside remains behind every detail. A crowded road now lies on the same planet that once appeared without borders. A cloud overhead is one small part of a weather system once seen stretching across thousands of kilometers. Familiarity returns, but its meaning is no longer entirely the same. Many astronauts have described how their idea of home expanded after the mission. Their hometown, city, and country still hold a distinct place in memory, but they are no longer the final layer of identity. Behind them lies a larger home, where every border exists beneath the same atmosphere. A sense of belonging to Earth does not replace earlier attachments. It surrounds them. Some people devote more time after returning to education, environmental conservation, or sharing images of the planet with the public. Others continue their technical work, scientific research, or family lives without turning the experience into a public mission. There is no single response that fits everyone. Sometimes, the only change lies in the way they see the smallest details of an ordinary day. A breath is the simplest example. On the ground, air enters the lungs with almost no need for attention, while aboard a spacecraft, its composition must be continuously monitored and adjusted. Once someone has seen the atmosphere as a thin layer around the planet, each breath carries a connection larger than the body itself. It depends on an atmospheric system, shaped and sustained by geology, oceans, and life across immense spans of time. A glass of water is no longer merely an object held in the hand. That water may once have been part of a cloud, an ocean, a river, a glacier, or the soil before passing through treatment systems and reaching a person. After it is used, it continues back into the environment or is recycled along other paths. Every small amount of water belongs to a cycle far greater than itself. Rain on the ground is usually experienced through sound against a roof, wet streets, and a drop in temperature. From orbit, the same event is part of enormous cloud systems carrying moisture and energy across many regions. A local rainstorm is therefore not entirely separate from the oceans, winds, or temperatures elsewhere. Distance reveals connections that daily life often hides. Someone living on the other side of a border may speak a different language, follow another tradition, and understand history from a different perspective. Even so, they breathe from the same atmosphere, depend on the same sunlight, and live on the surface of a single planet. This truth does not erase disagreements or make every society alike. It simply adds a shared foundation upon which all differences must exist. Even a nighttime power outage can bring that scale back into view. From orbit, city lights form vast networks, making civilization appear like a glowing layer spread across the continents. When the electricity goes out, darkness quickly returns, revealing how dependent that light is on a thin layer of infrastructure across the surface. Beneath modern technology remains a natural world governed by laws far older than humanity. Changes in perspective do not necessarily lead to grand declarations. They may appear in using water more carefully, paying closer attention to the sky, or recognizing that a local decision can have effects far beyond where it began. No single action is enough to solve every problem facing the planet. Yet, an awareness of connection can make small choices feel less isolated. It is important not to reduce the astronaut's experience to a simple moral lesson. Seeing Earth from space does not automatically make someone a better person, nor does it produce one universal answer to complex problems. Emotions may be powerful, but they are still shaped by circumstances, beliefs, and individual limitations. A wider perspective only opens another possibility for understanding. How it is used remains a personal choice. Not everyone will have the opportunity to leave the atmosphere and look back at the planet. Most of humanity will spend an entire lifetime beneath the same sky, knowing Earth's shape only through science, images, and imagination. Even so, part of that shift in perspective can begin without a journey into space. The photographs sent home have become shared windows for everyone who has never left the ground. Earthrise placed a colorful Earth above the gray horizon of the moon. The blue marble revealed an almost complete world, with oceans, clouds, and continents clearly visible within a single frame. The pale blue dot pushed the distance even farther, until the planet became a point of light that was barely recognizable. These three perspectives offer three different degrees of the same truth about scale. An image cannot fully recreate the feeling of being outside Earth. The viewer still knows they are sitting safely in a room, surrounded by air and familiar sounds. Yet a photograph can allow the mind to step outside the scale of everyday life for a moment. Within only a few minutes, a personal problem can be placed beside a finite planet and an expanse far greater than the planet itself. Virtual reality technology has been used in several experiments designed to recreate the view of Earth from orbit. Immersive imagery, sound, and the sensation of movement can create a stronger sense of presence than looking at a flat screen. Some early studies suggest that such experiences may increase feelings of awe or connection with nature. However, there is not yet enough evidence to conclude that they produce lasting changes comparable to an actual spaceflight. The difference is that astronauts cannot simply remove a headset and immediately return to a familiar room. They truly live inside a small cabin, with vacuum outside and the entire world continually present beyond the window. The view repeats itself between work, sleep, and the real situations of a space mission. That prolonged experience is difficult to reproduce completely through imagery, no matter how convincing the technology becomes. Nature on Earth can also create moments that change our sense of scale. Standing before the ocean, a person cannot see the opposite shore and is forced to experience a space far larger than themselves. From a mountaintop, the city below shrinks into clusters of light and thin lines. Beneath the night sky, the distances to the stars make the span of a human life seem brief. Watching a storm from far away can create a similar feeling on a smaller scale. Clouds form enormous structures, moving with currents of air that the human eye cannot see. The observer realizes they are living within a larger system, rather than standing apart from nature as an independent being. Awe emerges when the boundary between an individual life and the surrounding world becomes less distinct. These moments are not replicas of the overview effect. They do not carry the same distance, isolation, or direct awareness of the atmosphere's thinness. Even so, they can help people pause a perspective focused entirely on whatever is immediately in front of them. The goal is not to imagine being an astronaut, but to expand the scale within which life is considered. A problem may feel enormous within a single day, yet smaller when viewed across many years. A difference may divide two communities, even though both still depend on the same water source or climate. A wider scale does not erase pain, but it can prevent that pain from occupying the whole of a person's understanding of the world. This may be the most practical value that the view from space can bring back to Earth. Humility does not mean regarding humanity as meaningless. Civilization may be small before the universe, yet it is capable of building a spacecraft that travels billions of kilometers and then turns its camera back toward the place where it began. A brain formed on a small planet can measure the distances to the stars and recognize its own position among them. Physical smallness exists alongside an extraordinary capacity for understanding. Astronauts do not discover that Earth is too small to deserve our concern. They see the opposite. Everything important is concentrated on one world with clearly defined limits. There is no second ocean nearby to replace this one, no reserve atmosphere, and no other forest waiting beyond the planet. Finiteness increases value rather than diminishing it. Every forest is part of the only living system yet confirmed to exist. Every city contains people who cannot be seen from orbit, but who still carry memories, hopes, and fears of their own. Each life occupies only a tiny part of the surface, yet its meaning cannot be measured by area. Distance makes everything smaller to the eye while allowing its value to grow within the mind. When astronauts return, they walk upon the same ground they knew before the mission. Gravity still pulls their bodies downward, the sky still stretches overhead, and the horizon once again hides the rest of the planet. Only one thing has changed. They now know that beyond the horizon lies not another world, but the continuation of the same home. Once that awareness appears, Earth can never look entirely the same again. The planet continues turning in the darkness, carrying oceans, clouds, forests, cities, and billions of lives. No special light marks its importance to the universe. That value exists within everything being sustained upon its surface. A small world does not become less meaningful. Its smallness and finite nature are precisely what make it irreplaceable. Inside the International Space Station, the cupola windows remain turned toward the planet. Earth continues drifting below, neither hurrying nor pausing to be observed. A thin band of sunset appears along the curve, blending blue, orange, and profound darkness. Only a few minutes later, those colors fade away, leaving night to spread slowly across the oceans and continents. From the ground, Earth once seemed so vast that its limits could never be seen. The horizon always concealed what lay beyond, making every city, forest, and ocean appear as though it might continue forever. Human beings grow up with the sense that the world surrounds them, and that the sky stretches endlessly overhead. Only after leaving the surface does the true shape of home begin to emerge. From low Earth orbit, the horizon becomes a clearly defined arc. Clouds lie below, continents drift past the window, and day and night alternate in roughly 90 minutes. Earth is still immense, still filling almost the entire field of view, but it is no longer an infinite plane. It has a curve, a glowing edge, and darkness surrounding it. From the distance of the moon, the planet shrinks into a blue and white sphere suspended above a gray horizon. Individual cities disappear, along with roads and the named regions shown on maps. Every place humanity has ever known appears within a single frame. Beyond that sphere, there is no other living world close enough to take its place. Farther still, from the position of Voyager 1, the entire planet becomes a point of light that is almost impossible to recognize. The blue of the oceans, the white of the clouds, and the curve that once filled astronauts with wonder have all disappeared. Earth occupies only a tiny fraction of the vast image. Yet every human story remains contained within that faint point of light. Distance has removed one layer of detail after another. First, the houses disappeared, then the cities, nations, continents, and finally the shape of the planet itself. But what vanishes from sight does not lose its meaning. When every distracting detail is removed from the frame, one simple truth remains. This is the only place where every human experience has ever unfolded. Every laugh ever heard began within that atmosphere. Every loss, encounter, discovery, and hope belongs to the same finite surface. No part of human history has taken place outside that point of light. Smallness does not make these things less important. It makes them irreplaceable. Below the window, a city is entering the morning. Its lights gradually fade as sunlight reaches the buildings, while the streets begin filling with movements too small to be seen from orbit. Somewhere else, night has just arrived, and a family is preparing to sleep. These two lives, separated by thousands of kilometers, still exist beneath the same layer of air. Over the ocean, a region of clouds is beginning to curl into a storm. Water vapor rises, winds begin circling an area of low pressure, and bands of clouds spread across the sea. Farther north, snow is falling over a mountain range, covering stone and forests with a new layer of white. From space, all of these are only small movements upon the same planet. Rain is falling in one place, while another is suffering through drought. A child has just seen light for the first time, while an elderly person is remembering years long past. None of these moments knows of the others, yet all are held within the same system of water, land, air, and light. The thin blue atmosphere surrounds every difference without dividing them. The fear astronauts feel does not come only from seeing how small Earth is beside the universe, nor does it arise from a mysterious danger waiting somewhere in the darkness. It appears when they understand that the entire familiar world is concentrated in one finite place. There is no reserve atmosphere, no second ocean, and no other home close enough for humanity to reach with ease. Yet this realization does not have to lead to despair. Something becomes precious not because it is large, but because of the irreplaceable meaning it carries. Earth is small before the universe, yet large enough to hold oceans, forests, cities, and billions of lives. Its finite nature is precisely what makes every part of the planet worthy of greater care. Through the cupola windows, the final band of sunset disappears, and the dark side of Earth comes into view once again. Cities glow like delicate networks across the surface, while beyond them lies a blackness with no visible end. The planet continues turning, carrying everything humanity has ever loved, feared, and given a name. From far enough away, this home may become too small to see, but it has never become small in meaning.